vectors are fundamental across math, physics, and sciences, but they're only taught quite late. This video is an introduction to vectors for everyone, no matter who you are. We're going to start off with what is a vector and just how to think about them very concretely. Firstly, a vector is just an arrow. That's all I want you to think about. A vector is just an arrow. So I'm going to draw some vectors on the board. That's a vector, could be a long arrow, could be a short arrow. These are all examples of vectors. Now, what information does a vector encode and why are arrows so important? Well, firstly, a vector encodes a direction and a magnitude, which we also call a length. How long is the vector and where it's pointed. And these are fundamental because they describe so many day-to-day situations that we take for granted. For example, wind. At a point, at some place, the wind is heading in some direction and has some speed. So it is a vector. It has a direction and it has a magnitude. Similarly, if you're moving or you're running or you're walking or you're driving in a car, how would you describe your journey? You would specify a direction and how fast you're going. So these are day-to-day life situations where we need to think about vectors, okay? Now here what I've drawn, in the examples I gave you, for example with wind, the vectors can be arrows that can not necessarily lie on something like a whiteboard, but can go out of the whiteboard, okay? They can face in any direction you like. So my hand here is pointing out in various directions. These are all examples of vectors. They're all of the same length because my hand is the same length, but they're pointing in different directions. So here these are what are called vectors in the plane, okay? So they are two-dimensional vectors because to specify a point on the whiteboard, you just have to specify how far you go to the right or to the left and how far you go up or down. But to specify a point inside our universe or our space, we have to also specify how far we come out of the whiteboard. This is the third dimension. Okay, so here are vectors in the plane. Now vectors are super powerful because you can do lots of operations with them that you can do with numbers. For example, if you have a vector, you can scale the vector. So here we have this vector. Vectors are typically denoted by something like this. Here I've denoted a letter V with an arrow, V for vector. Now this vector, you can scale it. What does that mean? Well, scaling a vector is you can, for example, so maybe I will do it with a slightly smaller vector. I will draw it here just so I can write it out on the board. So this is a vector V. 2 times V is the same vector except its length is twice. So it's the same direction, but its length has doubled. So here, if I double the length, I would get this vector, which I'll draw here. This is 2 times V. So notice here when I've drawn vectors, it doesn't matter where they start and where they end, because once you know the direction and the length, you can figure those two things out. Once you know the starting point, you can figure out the ending point. But I'm not thinking about that right now. I'm just thinking about them as arrows. So now you have the vector 2 times V, which is denoted here. You can also scale a vector by a fraction. For example, half times V. So here you have twice of V. You could also have a vector which is half the length of V, but in the same direction as V. This is called half V. Okay, so here are examples of scaling vectors by numbers. Okay, now what happens if you multiply a negative number by a vector? In that case, you flip the direction of the vector. We already understand this in the case of the number line. In the number line, if you have the number line here and you draw a number like 2, negative 2 is kind of in the opposite direction. 2 is to the right of 0, negative 2 is to the left of 0. In the same way, if you have a vector, like I'm going to draw it here, if I have a vector W, okay, W is another common notation for vectors. Here we're going to call this vector W. Negative W is the vector in the opposite direction to W. So it goes in this direction. This is negative W, or sometimes what we call negative 1 times W. Okay? So typically we don't denote the multiplication sign. We can just write it as negative 1W. And then what is negative 2W? Well, it's going to be the vector in the opposite direction as W, but twice the length. Okay, so this is negative W. You could have a vector like this, which is going to be negative 2 times W. Again, I'm not worried about where the vector starts and ends. I'm just focusing on the direction and the length. Okay, so these are just arrows. So these are all examples of how to scale vectors by numbers. Now you can also add and subtract vectors, which is really, really cool. They just behave like numbers in this way. And you may ask, why do I want to scale or add and subtract vectors? There's a very natural motivation for that. So in terms of why we want to add vectors, well, we want to add vectors because suppose I'm giving you directions, okay? So suppose I tell you, you start off somewhere. Suppose I tell you, let's say this is your house, okay? You're starting at your house. Suppose I tell you you want to walk 100 steps in some direction, okay? That is basically specifying a vector. It's a direction and it's a magnitude. So if you want to go 100 steps in some direction, say I go in this direction, I ask you to go 100 steps, this is going to be a vector. Now suppose I want you to go to a particular place and I say go 100 steps in this direction, then go 30 steps in another direction. Okay, so for example, go 100 steps in this direction. This is a vector which we call v. Okay, so I've used w already. U is another letter we use for vectors. Okay, so this is a vector called v. Now suppose I then tell you, as I said, to go 30 steps in another direction. So let's say I say go 30 steps in this direction. Okay, so this is going to be called the vector w. It has a direction and a magnitude. It's sort of 30 steps and it's a specific direction. This is our vector w. Now I could just as well, instead of telling you to go 100 steps in this direction and 30 steps in this direction, I could have just as well told you to go straight to the place. And that is also a vector, right? To go straight to this place, it may not be any more 100 plus 30 steps. It'll be faster to always go straight directly. But whatever it is, we call it the sum of the two vectors. Okay, so here in this picture, we're going to draw this with a dashed line. So this dashed line here, this is what we call the sum v plus w. Okay, so all it is just the straight line path. Instead of going by v and then going by w, you go straight, we call that v plus w. So this is how to add vectors, and it's so beautiful because you can visualize it. You know, it's not like adding numbers, it's sort of numerical. You say 18 plus 20 is 38. Here you're really visualizing it as arrows adding up with each other. Okay, so what you want to do is you want to take your first vector, make sure it starts somewhere, make sure its tip end, right? Its end point is the beginning of the next vector. And then you sort of do that, and then you add, and you get v plus w. Okay? Now adding v plus w turns out to be the same as adding w plus v. And this is a beautiful picture, which is a parallelogram. So what we can do is, instead of going v plus w, let's go w plus v. So I'm going to draw this here. Okay? So this is kind of, I'm sort of going to try to make this very parallel to w. Okay? So this is w. And then I can go straight, and this is going to be v. So you see, instead of going first in the direction of v and then in the direction of w, I'm going first in the direction of w, then in the direction of v. So this time we're sort of adding v plus w, and in the other case we're adding w plus v. And this is a usual law we know from usual addition of numbers, that adding numbers, the order doesn't matter. It's the same with vectors. And in the case of vectors, it's a beautiful picture like a parallelogram. So this is how we add vectors. We can scale vectors, and we can also understand. So for example, I talked to you about what minus of a vector is. Does it behave like minus of a number? Because we know if we take 2 plus minus 2, what do we get? We get 0. So what happens if we take a vector and add it to negative of itself? Well, again, this is kind of a degenerate picture. It's not like this. Degenerate in the sense that, how do we add vectors? You make the end of one vector the beginning of the other. Okay, so the end tip of one vector is the beginning point of the other vector. So if we want to add v plus minus v, okay, how do we do that? Well, we think about what v and minus v are. If v is a vector like this, then minus v is the vector in the opposite direction, right? Okay, so how do we add the two vectors? You have to make it so that the beginning of the second vector, which is minus v, is the end of the first vector. Now if you do that, what are you going to get? You're going to get a vector once you put minus v like this. So you're going first along the vector v in some direction for some number of steps, say, and then you're going backwards in the opposite direction with the same number of steps. What are you going to do at the end? You're just going to land up in the place you started with. So v minus w is going to be a vector that is just a single dot. Okay, just a single dot. You can draw it here as well. Just a single dot. It doesn't have any magnitude. It doesn't have any length. And it doesn't even have any direction. And this is a vector which is very special. We call it the zero vector. Okay, we call this the zero vector. We denote it by 0. All vectors we denote with an arrow above it, because sometimes if you do algebra, you know these letters mean something. They could mean numbers. So these are just to make clear that you are using them to denote vectors. Okay, so that is a zero vector, and you have this cool law that v plus minus v is equal to 0. And you can also subtract vectors the same way as you add them. Okay, so, and a cool way of thinking about vector subtraction, this is sort of to practice, right? Once you have addition and you know what minus of a vector is, you can have subtraction. Okay, so v minus w is v plus minus w. Okay, just like 2 minus 5 is 2 plus minus 5. But what you can do is, if you want to say, here's a vector v, right? Here's a vector v, and here's a vector w, okay? This is a vector w. What is w minus v going to be, for example? What is w minus v going to be? If we think about addition, w minus v is typically, so I'm actually going to just make their endpoints just the same so you can see this. W minus v is what do you have to add to v to get w, right? 5 minus 2 is what you have to add to 2 to get 5. So that's going to be another vector. What do I have to add to v to get to the w vector? Well, I'm going to have to add this. So this vector is going to be w minus v. Okay, so a cool way of thinking about subtraction is you're kind of, for addition, you're filling in the last side of the triangle. For subtraction, you're filling in another side of the triangle as well. So I've told you how to add vectors, how to scale vectors, how to subtract vectors, and there's so much more to vectors. Okay, so vectors are so fundamental in math and physics. They're used to describe forces. They're used to describe so many things in math. They lead to a lot of advanced math. And I will do that in future videos. And please share with as many people as possible, friends, family, classmates, students, because anyone can understand this. You know, vectors are typically taught sometimes close to the final grade of school. Some people never learn about it in school. Most people don't, I would say. They only learn about it in college when they study sciences. But it's such a basic topic in some sense that anyone can understand. And it's so cool to introduce this math to kids, to young people, to anyone, you know, who doesn't feel they know math, but just to show something really beautiful. I really love especially how we can visualize addition like this, which is something different from number addition. So check out all the content on my channel. I've got lots of content across all levels of math, beginner stuff, advanced stuff. I want to build a library of math for all levels. And please subscribe, like, share, and I'm super excited to see you in the next video. I wish you all the best. I hope I was able to support you with this content, and I will see you in the next video.